Hello again, welcome to the MathTablet. In this session of the coordinate geometry series, we're having a look at parallel and perpendicular lines. Okay, we're going to revisit the equation of the line and we're going to revisit the ideas of gradient. Okay, now for two lines to be parallel to each other, that would mean that the gradients need to be the same. Must be the same. Okay, so if I've got, say, two lines y equals m1x plus c and another line y equals m2x plus c, if they're parallel, that means that m1 must be equal to m2. Okay, so let's have a look at a quick little example. Find the equation of a line parallel to y equals say x over 2 plus 10 and passes through 0, 1, say. Okay, now in a question like this, the first thing to do is to get the value of the gradient, the coefficient of x. Okay, the coefficient of x. So in this case, my gradient here is actually a half. Yeah, because x over 2 is the same as a half of x. So if the value of m1 is going to be a half, that means that the equation of the line that I want has to also have a gradient of a half. Okay, so this implies that my equation of the line will look like y equals half x, or x over 2 plus c. Then again, to find that value of c, I need to substitute a point that belongs to the line. So we're told in the question that it needs to pass through the point 0, 1. So I would sub that coordinate into the equation to find the value of c. So instead of y, I would have 1. Instead of x, I've got 0. That means c must be equal to 1. Therefore, my answer would be the equation of the line would have to be y equals x over 2 plus 1, or if you prefer, 2y equals x plus 2. Now, let's have a look at the perpendicular lines. So, for lines to be perpendicular to each other, and remember we had this a moment ago, right? For the lines to be perpendicular to each other, the product of the two gradients must be equal to -1. Okay, so this is definitely one to remember. The parallel one is fairly obvious. It's logical that the two gradients would have to be equal if they're parallel. But for them to be perpendicular, in other words meeting at right angles, the product of the two gradients would have to be equal to -1. So here's an example. Find the equation of the line perpendicular to, say, y equals 3x minus 1 and passes through maybe -1, 6. Okay, so in this case, the equation here, y equals 3x minus 1, tells me that my first gradient is 3. Right? So for the line that I want, which has to be perpendicular to this one, means that the gradient I want must be -1/3, because then 3 times -1/3 will give me -1. So that implies then my equation of the line will be y equals -1/3 x plus c, right? Or y equals -x over 3 plus c. Now I'm just about there. To find that equation of the line, I just need to substitute in a point that belongs to the line. So again, substitute the point that we've got. Instead of y, I've got 6, and instead of x, I've got -1, so that's going to be 1/3 plus c, which means c must be equal to 6 minus the third, or 5 2/3, okay, which we can write as 17/3. We usually stick with improper fractions when it comes to finding the equation of the line. So this then means my answer is going to be y equals -x/3 plus 17/3. That's the equation of the line. Or if you prefer, 3y equals -x plus 17. Just multiply everything through by 3. You could even go as far as y equals 3y equals 17 minus x, just to make that first coefficient a positive one. Any of those would be fine in terms of giving that as an answer. Thank you for listening into the Math Tablet.